Hello, this time we're going to discuss Article 104. The right angle ACB revolves around its vertex C, and its sides meet the two fixed perpendicular lines OAX and OBY in points A and B. We are asked to find the locus of the centroid of triangle ABC. Most of us had difficulty constructing a diagram that satisfy the given condition, but it seems that this is the correct situation after discussing it with most of you. Okay? So, first thing that we did was to construct two perpendicular lines OAX and OBY, or OX and OY. And it seems that OX is the x-axis, and I made OY the y-axis. So A is the one that is dependent on line OX, and C is an independent point. So I guess what we can do is to construct a line perpendicular to CA. There you go. And definitely it will intersect this line at the point that I want it to be, which is point B. Okay, point B. Hence, I can now hide this one and construct line BC, and I have triangle ABC, and it's a right triangle. So let's make this one 90 degrees. Very good. And remove that one, and then remove that one, and that's it. So all that I need to do is to find the measurement of to construct first the centroid. Okay, and here's what I've got. So first we can construct the circle, and since this is a right triangle, the best thing I can do is just construct the midpoint of segment AB and construct the circle that passes through this triangle. And definitely this particular circle will also pass through A, because OAB is a right triangle and ABC is also a right triangle, and vertex angle is O and vertex angle is C in this case. Okay, and this is point M. Yes. Okay, now we need to construct the locus of G. So the three medians, these are the three medians. One, get the midpoint, and connect B to the midpoint, and connect A to the other midpoint. And these are the three medians, and they all intersect at point G, which is the centroid. Let's change the colors and make this one thinner, and change the color just to make sure that it is let's make it orange this time, and that's what it is. Okay, so what we want right now is to find the locus of G. If I construct the locus of G, it will be dependent on point A, as A moves along this x-axis. Let's find the locus of G. Construct the locus of G, and whoa, it seems like a straight line. It makes a straight line. Let's make it thicker. So that is the locus of G. But wait a minute. So yes, as I move the triangle along the x-axis, C is fixed. Okay, G moves only on this line. That seems to be just the hypotenuse of this other triangle here, this particular triangle. Okay? So, let's consider the midpoint, the locus of M. Oh, by the way, yeah, the locus of M as A moves also, and construct that locus. And it seems like the locus of M is parallel to the locus of G. And why is that possible? Well, let's see. Well, M is the midpoint of the hypotenuse. And in that case, M is the center of the circle also. So, OM is equal to CM all the time. OM equals CM all the time, since M is the midpoint of segment AB, and it is the center of the circle. Cool, huh? Now, as a matter of fact, triangle OCM is an isosceles triangle. And triangle OMC is an isosceles triangle. And because it's an isosceles triangle, M, thus the locus of M is the perpendicular bisector of segment OC. Let's locate the midpoint of segment OC. That's the mid. That's there you go. That's the midpoint. This is the midpoint of segment OC, and it's perpendicular, and M passes through this line all the time. Cool, huh? But wait a minute. G is always a trisector of CM. Centroid G is always a trisector of median CM. And thus, Thus, locus, the line locus of G is homothetic to line locus of n with C as the center of homotety, and the ratio of homotety is 2:3. And that's it. Cool, huh? And that's all. Thank you very much for listening. Bye.